Hello everyone. In the continuation with respect to the composite materials, the first we will discuss about the importance of the fiber reinforced composite and also especially the fibers in the composite materials. Fiber is one of the oldest engineering materials which is used for so many applications. If you take an example of the ropes, nets and even the what we can say the antiquity pieces where the materials like either it may be a jute or the flax or the hemp are used as a reinforcing material. The plant fibers and animal fibers are used in the manufacture of the papers, brushes and heavy structural cloths. The many of the synthetic fibers are have been developed to replace the natural fibers because of the synthetic has more predominantly and uniform in size. The engineering purpose, the glass, metallic and organically derived synthetic fiber are most significant in the present day engineering application. Nylon is used as a blending material in so many applications like either it may be in the case of the belts or it may be in the nets or it may be the hoses or it may be the ropes or it may be the parachutes, the ballistic cloths or even in the reinforcement in the tires. The fibers, the glass fibers have the high strength, the low stiffness and as well as the high density and low cost. The graphite fibers have the high strength, low cost and less dense than that of the glass and boron high strength and stiffness, high density, highly density aramid, highest strength with weight ratio of all the fibers. The high cost of other fibers, nylon, silicon carbide, silicon nitride, aluminum oxide, boron carbide, boron nitride, tantalum carbide are some of the fibers which are having the major application in the industries. Now, the role of the matrix in the composite material. The choice of the matrix is a major factor in the engineering materials. The choice of the matrix, either it may be in the case of the MMCs or it may be the PMCs or it may be the CMCs, makes the engineering application desirable. In the case of the MMCs, a alloying material, the matrix material is plays a major role. One of the particular importance is whether the composite is to be a continuously or a discontinuously reinforced. The use of the continuous fiber and as a reinforcement may result in transfer of the most of the load to the reinforcement filament and hence the composite strength will governs primarily by the fiber strength. The primary role of the matrix alloy then are to provide a efficient transfer of the load to the fiber and to avoid the crack propagation in the composite. Especially the basic application of the matrix is the lowers the strength and as well as the more ductile and tougher the matrix alloys may be utilizes a continuously reinforced composites. For discontinuously reinforced composites, the matrix may gauns the composite strength, then the choice of the matrix will be influenced by consideration of the required composite strength and the highest strength matrix alloys may be required. Depending upon the type of the application, even this matrix will also vary. Now, in this slide, we will discuss about the functions of the matrix. In a composite material, the matrix material serves as the following functions. The first major function is nothing but the holding the fiber together and forming a composite material, and it also protects the fiber from the environmental wear and tear and even the aberrations. Distribution of the load evenly between the fibers is another major function of the fiber, which is also subjected to the same amount of strain as that of the fiber material, enhancing and as well as the transverse properties of the laminate. and improves the impact and as well as the fracture resistance of the component. The matrix also helps to provide a propagation of the crack growth through the fiber by providing an alternate failure path along the interface between the fiber and as well as the matrix material. Matrix also carries a interlaminar shear. The desired properties of the matrix. The need and as well as the desired properties of the matrix is most important for a composite structure. The main important properties are the reduced moisture absorption, low shrinkage, low coefficient and as well as the thermal expansion and good flow characteristics so that it can penetrate in the fibers bundles completely and eliminates the void during the compacting or it may be in the curing process. The reasonable strength, modulus and elongation is also a major desirable properties of the matrix. The most the matrix must be elastic and it also transfers the load to the fiber. The strength to elevated temperature is also most important. The low temperature compatibility, excellent chemical resistance and should be easily processable into a final composite or a compact shapes. The factors should be considered in the selection of the matrix. In the selection of the matrix material, the following are the factors to be considered are the matrix must have a mechanical strength compensate with that of the reinforcement, both either it may be a compatible in the taking the load and also distributing the load even to the reinforcement. Thus, if the high strength fiber is used as a reinforcement, there is no point using a low strength matrix which will not transmit the stress effectively or efficiently to the reinforcement. The matrix must stand up to the service condition such as either it may be a temperature or it may be a humidity, exposure to the ultraviolet rays environment and exposure to the chemical atmosphere, aberrations and or even for the dust particles where the aberration is a maximum. The matrix must be easily to use in the selected fabrication process. The life expectancy is another major factor in the case of the matrix selection. The advantages of the composite. The advantages exhibited by the composite material which are significant application in the aerospace industries are as follows: the high resistance to the fatigue and corrosion degradation and high strength or the stiffness to weight ratio as enumerated above, the weight saving which is significantly 25 to 45% uh, in weight in conventional metallic design. Due to the greater reliability, there are a fewer inspections and structural repairs is essential in the case of the composite applications. The directional tailoring capability to meet the design requirement. The fiber pattern can be laid in the manner that will tailors the structure to the efficiently sustain the applied load. The fiber to fiber redundant load path can also be very easily manipulated in the composite. The improved dent resistance is normally can be achieved very easily in the case of the composite material. The composite panels do not sustain the damage as easily as thin the normal gauge sheet metals where the dent is a predominant because of the impact. It is easier to achieve a smooth aerodynamic profile for the drag reduction. The composites offer a improved torsional stiffness. This implies a high whirling speeds and reducing number of intermediate bearings and support of the structural elements. The overall part count and the manufacturing and the assembly costs can be reduced very predominantly by using the composite material. The high resistance and impact damages can also be achieved. The thermoplastic having a rapid process cycle, making them attractive for a high volume commercial applications that traditionally have been to domain the sheet metal. Moreover, a thermoplastic can also be reformed. Like the metallic, thermoplastic have a indefinite shelf life. The composites are dimensionally stable and also they have a low thermal conductivity and low coefficient of thermal expansion than that of the normal conventional materials.